Okay, so welcome to our Introduction to Networks class for the week of 4/23. We're getting toward the nitty-gritty, folks. One thing I will tell you is the official class end date is May 9th, but if you do not finish exactly by then, I'm not going to kick you out of the class and or jump up and down on you. I will tell you this, you will lose access to the Moodle portion of the class, so I need you to log into moodle.stanley.edu and just kind of show attendance there. And I also need to warn you that right after the week of May 9th, we are going to actually be moving to a new data center. In fact, they pull power tomorrow. That's why I sent you that email about the power being down tomorrow afternoon for NetLabs. They're putting in our transfer switch and connecting the data center to our main power for the building, so I take the whole power on the building down. But after May 9th, the week after that, the access to our NetLab system is going to be spotty. So if you know that that's going to be a great week for you, then I would suggest working on trying to get as much of your labs done now and then save your packet tracers for that week. So that would be the week of like the 10th through the 17th or so. And I'm sure my math there is not great, but that wasn't too bad. The 14th through the 18th, that week we will probably be moving into a new data center. So be aware of that. Just kind of throw that out there. It will be spotty as we move stuff across. I'll try to get up as soon as possible. Hope to do it pretty quickly, but it just depends on how things work as we move it over. We're actually going to reload our entire system with a new VE version of NetLabs. So I will actually be creating you new accounts, and I'll save the old information so I can look and see what labs you've done. But then you'll have new labs and new items to get a hold of. So we'll see where it's going to go. I'm not real sure exactly where I'm going with that. I wish I had a clean cutoff date, but there's never anywhere clean to cut off with the classes that we have. The other thing, again, is for this class, I don't know why I just clicked the security class, but I did. For this class, as you continue to move forward to try to complete it, remember, I want you to do all the hands-on labs. Those are the labs that are in netlabs.stanley.edu. I also want you to of one tracers per chapter and all the chapter exams, the filing exam, and then the skills exam, which is the skills exam I sent to you earlier last week. Be aware the skills exam is to be done in NetLabs, and also be aware that you cannot take the written final until you have completed the course feedback. So that is something you must do before you can do that. So right now, I'm actually going to open up for questions. I don't have a huge amount prepared for today because I really didn't know where we wanted to go. We talked about the transport layer last week. Hurling up a fur ball if you hear that in the background. I apologize. But we did talk about the transport layer, and we talked about how it works and the difference between TCP and UDP. We talked a little bit about windowing and session control. And then as we get in the application layer, one of the things I will stress here is this idea of the different protocols. And this will be something that most of you already know, but it would be something really good to spend more time with your students so they understand what is actually going on when they pull a web page off of a server. I get amazed by students who, we had a great discussion at lunch today about how so many kids are just crazy about Fortnite. My little 14-year-old nephew is wild about Fortnite. And they've got this new Fortnite version that's on a phone. And you sit down and you think about, well, what's really going on when you're playing even just a game online is kind of nuts. I mean, when you really think about the amount of data being sent, the number of requests and what's going on, we're sending things all the way across the world, and students are just like, oh yeah, I'm accessing the web page, whatever. They have no clue that each individual packet, each individual frame is being created, and all this work going on behind the curtain. I always tell people when they come through to look at my lab, I'm like, we're the wizards and wizards of Oz. I mean, we're the people who are behind the curtain pulling the levers to make all these things work. And then just as soon as, you know, it quits working, people finally realize, you know what I mean, I can't play Fortnite on my phone. And so it is very interesting to step them through these things and talk about how, you know, all of the things we've learned, folks, in this class, guess what? From this client to this server, you've got to have, you know, an ARP request. You've got to have an ARP reply. Well, first off, you got to have a DNS lookup, which they talk about in this. Then you have an ARP request, an ARP reply. Then I build my frame. It gets sent over here. In the network, it gets routed and gets, you know, the layer 1, layer 2 information pulled off by the routers. And then it gets changed out. Then it gets delivered to the HTTP server, which looks at the application information and figures out it's a GET request. And it just, all of that, and helping them to put this together, to me, is one of the more interesting things that we do. The difference between HTTP and HTTPS, also a very important, you know, difference between secure and not secure, and teach them how to tell whether or not something's secure by looking at, you know, right here, you can actually click here, and you can look at the certificate, and you can actually look at who issued the certificate. You can look at the statement of who issued it, and so you can actually look at who it's been issued to and what it's good for. So kind of neat there. Any questions on that? I don't really have a whole lot in this chapter because I think most of this you already know. Anybody know the difference between Pop and Imap? Both are used to retrieve email off the server, but what's the main difference between Pop and Imap?
Well, one of them leaves it on the server and one of them does not.
Correct. Pop does not leave a copy on the server. In fact, it pulls everything down to the client. IMAP gives you the option. Now, it doesn't always leave it on the server, but it has the option to allow you to leave it on the server if you want to. Both, however, are used for clients to retrieve their email from a server. SMTP is used for the information to go from a server. Brandon, I had to mute you. Let me know if you want to talk. SMTP is used to move information between servers. All right. All right, let's see here. Packet Tracer actually does a pretty good job showing web and email stuff, moving things around. Oops, what in the world? What did I just order from Microsoft Store? Probably my nephew, where he actually went and bought the Fortnite. He went and ordered the Fortnite Battle Pass the other night. I gave it to him for getting his grades up in school. DNS, by the way, this is one of our biggest problems in the world of security because of the lack of security in DNS and the fact it was never built to be secure. Because just think about it, if I can make it where you type www.cisco.com and you get an address that is the wrong address and I send you to a site that looks exactly like cisco.com, well, that can be an issue. Likewise, there's a thing called Localhost File, which is extremely dangerous that we talked about before. This is something I would know about, Quad A, and that is simply an A record for IPv6. Okay, so Quad A versus an A record. An A record is an end device in IPv4. A Quad A is an end device. In other words, when it says an end device, that's most commonly a server of some sort. Something else you'll learn about, especially if any of you are in my CCNA CyberOps class, or if you will be, you'll learn about the fact that DNS is actually being used to exfiltrate data, which is pretty interesting. Also, I didn't send this out to y'all, but I'm going to show it to you because I think it's absolutely amazing. Fish tank hacks. Check this out. Okay. Criminals used an IoT device in a fish tank. Okay. So in other words, there was a fish tank. There was an internet-connected fish tank, you know, and its job was to allow people to check the salinity and the water. But hackers usually secured to exfiltrate almost 10 gigs of data from American casino. Amazing. Who would have thought about it? I died last Thursday when I was at Skills USA. Always happens when I'm out of town. Something dies in the house when I'm not here. My wife calls me and says, "What's up?" Well, refrigerators with the built-in like home unit thing in it, and I was like, that would be wonderful if it wasn't $4,000 for number one, and number two, I was like, man, think about all this it's got to have in it. So it's pretty interesting that that is the kind of thing being used to get data out of a network. I mean, it's like 10 gigs of data from hacking a fish tank. So I told my security students that was a whole new type of phishing. I mentioned that because DNS is also being used exfiltrate data. They're using DNS requests, and those requests are actually hiding data that's being sent to a bogus DNS server, and it's being used, and then it's being recreated or reassembled there. I always talk about this, the root, top level and secondary level domains with my students. I'm sure most of you probably go over this with your students in your server classes and those things. They do show you the DNS lookup command, which is nice to show your DNS information. Or on Linux, you can use dig. And what's the other one on Linux? Anybody know? I forget. Dig's one. DNSSEC. Yeah, Brandon Kearns talks about DNSSEC. Yeah, that is a good thing. Let me go ahead and do this again. All right. Yeah, Brandon, DNSSEC is definitely big. So, yeah, you just got such an echo, Brandon. I don't know why. Could just be the setup I have here or something. But DHCP, this is pretty simple, dynamic host configuration protocol. One thing I do teach people is DORA, good old Ant DORA. So if you've never heard of Ant DORA, good old Ant DORA is the DHCP discover, offer, request, and acknowledgement. Discover by the client. It says, hey, are there any DHCP servers out there? DHCP offer. The DHCP server says, yep, I'm here, and here's an IP address you could use with some options possibly. The client then sends a DHCP request. Hey, that's a mighty fine looking IP address. Do you mind if I use it? And then DHCP server will be fine. You can use it. At that point, the client loads it into a TCP/IP stack and uses it. So I use the acronym DORA, or good old DORA, Ant DORA, so that people remember discover, offer, request, and acknowledgement. But it is a way that we assign dynamic IP addresses to a host. It's built from the BootP, which was used with the diskless workstations sometime. And one of the things, I talk about SMD, a little bit about that, but one of the things I really want to look at in the next chapter is I want to look at building a small network. One of the things that they did in this particular class that I like is that they went from just theory to now they're going to show you how to actually configure a network. So in our example for this particular class, we built a very simple network that's a router, a switch, and a couple devices. So we talk about creating IP addresses for a small network, making sure the end devices have IP addresses. In our case, it'll be a couple PCs that we're going to have for a hands-on test. And they also talk about redundancy in small networks, which is something we don't really have a great deal in a small network. You can see this little satanic attempt here at making redundant links. Even small networks are probably not going to have this, and 99% of the small networks will not have this. They're not going to have redundant routers going to the internet, especially small. Medium size, yes. Small, no. It's just too expensive. You know, my wife's business has a single connection to the internet, and if it goes down, well, we're out of luck until it gets fixed. But her business can also run without the internet. So it's not that big a deal if the internet's completely down. Now, trust me, they get pretty irate when it is, but their business doesn't stop. Traffic management, a little bit on this is covered a lot more later, but looking at prioritizing traffic, voice traffic needs to have higher priority than FTP or HTTP traffic because it's more important for it to arrive intact in sequence. And they talk about common applications, different things here. I really want to get to the configuration. Here's one thing I talk about: small network growth. Networks are like rabbits. Today you got 5 PCs. Tomorrow you'll have 25. I always teach my students that because it is amazing how quickly networks grow. And it seems like in the world of virtualized servers now they grow even worse because we have VM sprawl. That's many sprawls that things that are going on. If you will, mute yourself. Ooh, hit the wrong thing. There you go. All right, so let's get over here. They do a little bit of physical security. This is kind of the catch-all. A lot of these you'll see later. And all of this is kind of enabling SSH. By the way, this is something they do have you do, and it's something that you need to know how to do. SSH is allowing you to do a secure connection to the VTY lines of your Cisco devices. Students who were just in my Skills USA state contest had to configure SSH on all 4 devices, so they needed to know how to do it quickly and efficiently. But you see here, item number 1 is configure the domain name. The reason that's important is because that domain name is used as a seed when you generate the key. So you're going to configure the IP domain name. You're going to generate your RSA keys, and you can do either crypto key generate RSA general keys modulus 1024, or just crypto key generate RSA, and then it will ask you for the modulus. And the modulus is the size of the key. So the bigger the key, the more secure they're supposed to be. Then you will go in and create a user in a local database. And then here's one place that gets a lot of people in trouble. You go to the VTY line and you put login local, which says reference and log in using a local user in the local database. But by default in iOS 15 and higher, the current information is transport input none, which means even telnet is not allowed. So you've got to put in transport input SSH to allow SSH on the VTY lines. Once this is completed, if you've got connectivity, you'll be able to actually SSH between your devices. Very important because that cannot be broken. It's encrypted. All your information between the device and the device you're SSH froming, secure shelling from, is completely secure. Now, like I said, there's a slide on it. There is a packet tracer on it, and then it's on your hands-on final. And there's also a lab in NetLabs on it. So let's see, how many times is that? That's 1, 2, 3. What do I say when you see something 3 times? You better know how to do it. Okay. So you better know how to do it. Ping, simple command. The bang is a success. That's an echo replies come back. A dot is a timeout, and then U is unreachable. Typically, this means the router does not have a route to it. This means it may have gone that way and then it has not been sent back, and the bang means it worked. Okay, so a ping is a basic connectivity command. If you get a reply, everything's good. Okay, and that's on a Windows host. On a Cisco host, the exclamation point bang is the success. This is kind of neat. You use extended ping command. Let's say you wanted to actually ping from instead of, by default, if you ping from R1, the source is going to be, say I ping from R1 to R2, the source is going to be the closest interface by default, so this 225. If I do an extended ping, I can actually say source it from the inside, so source it from this 10.1, and that can help you figure out where there's some routing issues, whether or not R2 knows how to get back to R1, and if it could help you figure out routing issues on R2. So this will let you do this. Also, later on, you'll learn about NAT. So if you want to force a NAT translation, if you do a standard ping, it's just going to ping out this interface here, so there'll be no NAT or PAT. But if you ping sourcing from the inside address, it will NAT, because that will follow the, that'll actually hit the access control list for NAT. All right, let's see, jump on over here. Common show commands, so show running config, show interfaces, show IPM brief is my favorite, by the way. Okay. Show, and I'll go ahead and tell you this, show running config is not a troubleshooting command. It's usually a last resort. So I start almost every single time with show IPM brief, show IP interface brief, which lets me see the IP addresses and the status of the interfaces. I can then drill down into an interface by doing show interface and the individual interface, GI01, GI00, etc. I'll then do show IP route to see if there are some route problems, and then show protocols or show IP protocols. So I see what protocols are running. So here's seeing the protocols running, and let's see, that was show ARP. It's gotten pretty sideways if I'm doing show ARP. And show version, I use this sometimes. So for instance, I do a crypto key generate RSA, and it says the command is not supported. It may be that I'm running an iOS version that is not a K9 version. That version, if it's not a K9, it doesn't support the cryptographic features. So that's one way I can find that, by doing a show version. All right, let's see. Show Cdp Neighbors. This is a Cisco proprietary protocol, and I just used this the other day, in fact, when I was testing our state contest. But show Cdp Neighbors, if it is a Cisco device, it will show you all the directly connected Cisco devices. In other words, I was not getting the connectivity I thought I should be getting, so I want to make sure I was connected to the right port. So I did a show Cdp Neighbors details, and it can tell me what port I'm connected to locally and remotely. So I can see here that on the local interface is FA03, and I'm connected to switch 3's FA06, so that I'm able to see what ports are in what. So this is a very good command, and it doesn't require you to have IP addressing working. So you can have layer 3 messed up. Since this is a layer 2 protocol, all you need is for the interface to be up, and you can do a show CDP Neighbors detail or show CDP Neighbors, and it will show you information. Now here's the details again, showing you everything about the switch. It even shows you what version of iOS it's running on the opposite switch. Now, a lot of people turn off CDP because it can be considered a security hole, but it is also necessary for certain Cisco voice over IP functions, so you need to be careful depending on how your voice over IP is set up. But remember, it only shows directly connected neighbors. So R1, if you do a show CDP Neighbors, it's only going to show R2, and it's going to show this switch here. It's not going to show R3 because it's not directly connected. If you want to turn it off globally, do no CDP run, and that turns it off globally, and no CDP enable if you want to do it on an interface. You can actually turn it off on a per interface basis, which you may want to do on a switch out towards the switch and not turn it off on toward the router, depending on how your network performance is, or your network, security policy happens to be. Show IPM brief, my favorite, again, shows you the address, shows you the status. It does not, however, show you the mask. Again, I wish they would do that, but it doesn't. The debug command is a wonderful command and a super dangerous command. Do not, in any shape or form, ever type debug all in a production environment, because it will debug so much that it will actually lock you out of the console of your router and could drive your processor to 100% and cause your router to quit routing packets. So whenever you're going to run a debug, make sure you're running exactly what you need to debug and why. So debug IP OSPF adjacency, or debug IP, debug PPP negotiation or PPP authentication, or debug you know, IP, ICMP. Do not do debug all. Now you can undebug all, that turns it all off, but this is a super dangerous command that if you're doing the production environments, probably going to mean you got to reboot your router, turn it off, turn it back on to get back control of it. All right, questions. Let's open up the questions real quick. I'm going through stuff pretty quickly. I think most of this is pretty common though. Brandon, I did unmute you. Any questions?
I'm good. I don't know why I'm having such issues today.
It's the rain. We'll blame it on the rain.
All right, that works.
All right, so now troubleshooting. This is one of the hardest things because it's nature versus nurture. Can you make a great troubleshooter? I honestly don't think you can make great troubleshooters. I think you can make everyone a good troubleshooter, but you can't make people great troubleshooters. Experience makes you a better troubleshooter. The ability to kind of see things holistically makes you a better troubleshooter. Most of what I try to teach my students is troubleshoot using the OSI model. In other words, let's start at layer 1. Do I have a cable plugged in and do I have blinky lights? If I don't have blinky lights in the cable, it's probably not going to work. Look at layer 2. Is my interface up, up? If it's up, down, then I've got a layer 2 issue. Could be authentication. Could be some of those things that you'll learn more about as we move forward. Look at layer 3. Can I ping it? Can I do a trace route? This is a command we didn't really talk about, but it's one that you'll see when you read through the chapter. Can I look at the show IP route table and see the routes I should be seeing in the route table? Now, what I normally actually do is I just try to connect to a web page first. If that works, then you know everything below it's working. Because if layer 7 is working, pretty much everything else below it should be working. Sorry, I had to have a little something to drink. That's not always true, but sometimes. Then I'll start breaking it down by items and looking at different layers. Now, one of the things you really do need to do is identify the problem. I cannot tell you the number of times someone has called me and said, the internet's down. And I'm like, well, first off, I doubt seriously the internet's down. What can't you do? I can't get my email. Okay, so are you telling me when you open a web browser, you can go to google.com and go to this site and you can get there? Yes. Okay, so the internet's not down, but you can't get to your email. Now I've identified the problem. Then I start looking at probable causes, and the first thing I always ask is, what did you change? Their answer is, nothing. And I then go, tell me the truth, what did you change? At that point, they'll go, well, I needed this additional connector to do something with my Google, my Google Calendar and blah, blah, blah. Ah, okay, now we're getting a theory of possible cause here. But you do try to see if you got a probable cause, and you test the theory to see if it's a cause. That is the cause. You try something to fix it, and here's the key thing that so many people don't do. If it doesn't fix it, take whatever you did off. Undo what you did. Otherwise, you're introducing more problems, and you won't be able to tell what actually fixed the issue, or you may compound the issue. So once you test your theory and see if you can fix it, if it doesn't fix it, then definitely remove it and try again. So it's an iterative process. The other thing most people forget is, if it fixes it, document it. Okay? Document it. Otherwise, if you don't document it, how are you going to know when you hit the same problem again? I can't tell you the number of times I've done that, where I've fixed an issue, didn't document it, and literally 3 weeks, I just had it done today. I was trying to put auto paste a link in the Word, and I knew the keystroke to do it, and I had everything there, and lo and behold, I've been hit by a truck and couldn't remember it. So I was just like, yeah, ladies, I'm sitting here. If I had documented it somewhere, I would have it. So again, 6 steps of troubleshooting, and this is by no means, and Kelly, I had to mute you, you had a lot of feedback in yours too. This is by no means the only 6 steps of troubleshooting. But one thing I do like to teach students is you can all become good troubleshooters. Have a method of some sort. You don't have to use these 6 steps, but you need a method that you can apply consistently, and then you will become a good troubleshooter. Plus, what will happen is if you have a job interview and people ask you how you would fix a problem, if they see that you have a good, solid plan or a good, solid idea of how to do a methodology, it makes them more impressed with you and helps. Last but not least, if you can't resolve it, escalate it. I mean, what I do is call my friends. You know, I call people that I know that are experts in certain areas. And one thing I always tell people, if you are in this field and you think you know everything, or if you run into anyone who says they know everything, run screaming from that person as fast as you possibly can. Because that 99% of the time, that person is a complete, that person's usually a complete idiot. Because if they truly believe they know everything, they're dangerous. They're super dangerous. Had this problem this week too, something I never had an issue with between 2900 series routers and 2960 switches. The gig interface going to the FA05 would not auto-negotiate, so I had to put speed 100 and duplex full on the gig interface to make it work correctly with the FA05, the fast Ethernet. So be aware of that. And by the way, it was telling me right on. I mean, look, if you see this and you can't solve this problem, you got bigger issues. Okay. I mean, if your switch literally tells you duplex mismatch discovered on not half duplex, half duplex. Okay. So this is telling me that R1's gig 0 is gig 1 or 00 is half duplex, and I'm not half duplex. So just fix it. Now, in the world of auto-negotiation, they should auto-negotiate, but auto-negotiate doesn't always work, so you may have to go change it. IP addressing, most times just fat fingering, accidentally putting the wrong mask on something. I saw this this week. Somebody forgot to put their default gateway in on their PCs. And as a result, they had things right, but they could not get across. And as a result, they lost points. So they had to have the correct IP address, mask, and the correct default gateway, which is always the IP address of the closest router port that's on the same network as you. So that's basically what they're showing here. Wrong IP address or wrong default gateway. So, that's pretty much it, folks. By the way, the skills integration challenge would be a good place for you to kind of look at, working towards some things that would help you with the final. A lot of different things here that you could do that would be. And now let's look at this skills integration challenge. What's it asking you to do here, folks? It's asking you to do SSH. I'm actually going to stop the recording, folks, so we can just talk.